Okay. Unfortunately, the symposium's crashed and everything was lost. So I'm going to do the best I can without the note packet right on the screen. But hopefully this will follow your note packet closely enough. We're going to look at a hyperbola. Definition of a hyperbola is it's the locus of all points such that the absolute value of the difference of the distances from the foci to the hyperbola is a constant. So when we look at this, just going to give you the basic information and then we'll go over a problem. So if you have a hyperbola, let's say you have a vertex here at 4, 0, one here at minus 4, 0. Let's say you have an end point at 0, 3 and an end point at 0, negative 3. Then you're going to have a focus here at negative 5, 0 and one here at 5, 0. Hyperbola wraps around the foci like this. So if we think about the definition and choose a point P, look at this point P1, what the definition says, if I take the difference from this foci and from this point to this foci, it's a constant. So we can call this distance d1, this distance d2. So the absolute value of d1 minus d2 is a constant, and it'll be equal to any other difference that we look at. For example, if I choose this as P2, and I look at the absolute value of the difference in these distances, calling this D3 and this D4, D3 minus D4. Okay, if you remember from ellipses, this value is actually the length of the focal radii, which is that measurement between those two vertices, if you're looking at this parabola, okay? Now, that's the definition. Let's go ahead and can we insert a page here? And let's put some definition to the actual form of the parabola. So again, I'm going to have a parabola, and I'll have those vertices at 4, 0, and then the foci at 5, 0. I'm going to put end points here. Okay, so this is a sketch of hyperbola. I have vertices here and here. Now the length of this axis is still called the principal axis, but it's also called the transverse axis. Okay, that's also the transverse axis. This axis is now called the conjugate axis. Okay. Remember, the length of the transverse axis is also the length of the focal radii. If you remember from ellipses, when we talked about ellipses, from the center to a vertex is defined to be the value A. So that length is A. That is still true in a hyperbola. The length from the center to the end point was B, and that is still the case. And then the length from the center to the foci was C, and that is also still the case. Those definitions are the same. However, the relationship now changes. If you notice, C is actually the longest length. It's actually the furthest length from that center. So the relationship is now C squared is equal to A squared plus B squared in a hyperbola. So as we look at a hyperbola, a couple things are similar to an ellipse, and a couple things are just a little bit different. So the equation, standard form of the equation of an ellipse, that opens left and right. We're going to have also, this is going to open left or right. Left and right, not or, left and right. Make that an and right. Is x minus h squared over 2 minus y minus k, not over 2, that's over a squared, minus y minus k squared over b squared is equal to 1. This is an a, not a 2. This is a squared. Okay, and in an ellipse, if you remember, the position of the a in the equation dictated the orientation of the ellipse. So if a squared was under the x minus h squared, then the principal axis was parallel to the x-axis. If a squared was under the y minus k squared, then the principal axis was parallel to the y-axis. In a hyperbola, A remains in the same position and B remains in the same position. So when we look at how does it change when it is opening up and down, the equation is now y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, so what changes is the operation becomes subtraction, and what dictates the orientation is which variable is being subtracted. Is it the x minus h squared or the y minus k squared? So again, if it's opening left and right, it's the minus or minus y minus k quantity squared. If it's up and down, it's on the x. The negative is on the x. So I'm looking at this situation. That's the general idea. I'd like to actually look at a specific example in your note packet. We'll go to the first one so you can get an idea, just a general idea of what this looks like. So this example has x squared over 4 minus y squared over 9 equals 1. So when you look at this, you get the general idea that this is opening left and right. So you know, just in general, it's opening left and right. Let's look at some specifics. A is in the first position, or a squared is in the first position, therefore A is equal to 2, B is equal to 3, and C is equal to the square root of 13. This one, HK, is the center, and for this particular example, that center is at 0, 0. So when you're looking now, let's get specific about what this graph actually looks like. Okay, so my vertices now are going to be, and it opens left and right, so my vertices are going to be at 2, 0, and negative 2, 0. The foci are going to be negative root 13 and 0 and root 13 and 0. So that's a little bit more than 3, but not quite 4. So here are my vertices, and then there are the foci. So I'm just going to sketch that around a little bit. Then I'm going to have endpoints at 0, 3 and 0, negative 3. Okay. So when I look at this, then I can sketch in kind of this little rectangular box, and because I don't have this on a graph, it's probably going to be slightly off, but I'll try to give you the idea. I'm also going to still have key points. Remember, key points are calculated b squared over a, so in this case that is 9 over 2, or 4.5. Remember, key points are above and below the foci when it's opening left and right, and then it'll be left and right when it's opening up and down. So these key points, you'll go back to the foci, negative root 13, up 4.5, and then negative root 13, and down 4.5. Then you'll go to the other side, and it will be root 13 up 4.5 and root 13 and down 4.5. So those will be your key points. Another thing we have to calculate is something called the asymptotes, which you will remember from a couple chapters ago. The asymptotes actually go through the corners of this rectangular box. And the equations of the asymptote is actually this point slope form, y minus k is equal to plus or minus b over a x minus h when it is opening when it is opening left and right. So when it is opening this way, left and right, that's the equation. When it's opening up and down, it's going to be y minus k is equal to plus or minus a over b times x minus h. So it's just point slope formula. And if you go back to this particular example, when I'm looking for the equation of this line, you can think about the fact that this is the change in the rise over the change in the run. Well, what's the rise here? The rise is b. What's the run? The run is a. So for the equation of these asymptotes, it will just be y is equal to plus or minus 3/2 x for the equations of those asymptotes. It also asks you on your worksheet for the length of the transverse axis. The transverse axis is 2a, and the length of the conjugate axis is 2b. So in this case, 2a is 4, 2b is 6. Let's move on to one more example, because I'm running out of time today. Hopefully this will be enough information to help you at least get started. Okay, I think it's example number 3 here. It's 9x squared minus 54x minus 16y squared plus 32y equals 79. You're going to have to complete the square on this. You need to be a little careful with this one. So I have 9 times x squared minus 6x minus 16 times y squared minus 2y equals 79. So I'm going to complete the square here, which means I'm going to add 9. I'm adding 9, but I'm multiplying by 9, so I'm actually adding 81 to the left, so I have to add 81 to the right. And I complete the square on the y. I'm adding a 1, but I'm really subtracting 16 on the left, so I'm going to have to subtract 16 on the right. Write this as a binomial squared, so 9 times x minus 3 squared minus 16 times y minus 1 squared is equal to 144. Then divide each of those terms by 144, and you will get the equation x minus 3 squared over 16 minus y minus 1 squared over 9 equals 1. So there's the equation. From here you can see that your value of A is 4, B, your value of B is 3, and so then your value of C is going to be 5, because the relationship is now A squared plus B squared equals C squared. Your center is at 3, 1. Actually, let me write that. Okay, the center is at 3, 1. This opens left and right. Try to put a little picture down here. It's going to open left and right, so my center is at 3, 1, and it's opening left and right. So that means that my vertices are going to move 4 units to the left and to the right. So I will have minus 1, 1, and 7, 1 as my vertices. So here and out here. Then the foci are going to shift 5 units left and right of that center. So they will be at minus 2, 1 and 8, 1. So they're going to be out here and out here. That's a little off the page, but you get the idea. I need the space. The end points, my end points for this, I'm going to go to the center right here. Now the end points are going to shift up and down. So they're going to be 3 units up. So at a point 4 or 3, 4. Sorry, 3, 4. So at 3, 4, and then they're going to shift down 3 units, so at 3 minus 2. So here's my little rectangular box that the asymptotes will actually go diagonally through those corners. Now my key points, again, let's see, I'll try to fit them in down here. Key points are b squared, so 9 over a, which is 4, which is about 2.25. So to find my key points, I'm going to actually put them up here. I have to go to the foci. So here are my key points. Remember, they are above and below. So I'll go out to -2, and then I'm going to take 1 plus 2.25, or 3.25, and then 1 minus 3.25, which will be -1.25. I will then go to the other side, the other focus, which is at 8, 1, okay? So from that, I'm going to go up, so I will be at 8, 3.25, and I will be at 8 minus 1.25. So they will be here and here on either side of that vertex for the key points. The length of the transverse axis is going to be 2a, which is 8. The length of the conjugate axis is going to be 6. Now, this opens left and right, so again, when I'm looking for the equation of the asymptote, I'm looking at the vertical change, which is b, over the horizontal change, which is a. So I will have y minus 1 from my center is equal to plus or minus 3 over 4 times x minus 3. And then you multiply that out, you should get 2 equations, and you should put that in slope-intercept form when you're finished. I hope this is enough to help you get started on the homework. See you Monday.